because Mel started talking.
Alright, so my plan for this is to say this has got to match up with r sine theta plus alpha. And then I'm going to go to the formula booklet, if I can't remember it, and look up what it says about r sine theta plus alpha. It's in there as being sine A plus B, and it says it's sine A cos B plus cos A sine B. Okay, so we copy that out. And all that we do now is we match up the things that are on both sides of this equation. So we have a look on both sides. We've got a sine theta there. And so we match that up with the sine theta over there. And so if we compare the sine thetas, we've got 24 of them here. Has to be equal to r cos alpha on this side. And we do the same thing with the cos thetas. Over here, there are 7 of them. Over here, there are r sine alpha of them. So we're going to say that 7 must be equal to r sine alpha. You see what we've done there? It's just comparing the coefficients on the two sides. And then when you solve these simultaneous equations, you've got a number of routes that you could go at. You could go straight into a dividing one by the other to get tan alpha. I prefer to do it the other way. I prefer to think that if I squared and added these, I'd end up with cos squared plus sine squared in there somewhere. So I would get that r squared is 7 squared is 24 squared. It's Pythagoras' theorem, imagining what would happen within that triangle. Which gives me r squared is, it's going to come out to 25, isn't it? We get r is 25. We actually, strictly speaking, we get r is plus or minus 25. But this said that r was positive. So we only take positive one, the plus 25. Now we've got our simultaneous equations are even better now. We've now got that cos alpha is 24 over 25 and sine alpha is 7 over 25. Now this is all worked out really nicely because these are both positive. We're in the first quadrant, between 0 and 90 for both of them. So we get the same answer, and it's an inbuilt check as you're going through this. If you do inverse sine or inverse cos of these things, then you should get the same answer, and it's almost worth your while doing that check, putting them in and just making sure. We do it with, the question wants us to be in degrees, because it's said alpha is between 0 and 90 degrees. So, inverse cos I'm going to do on 24 over 25. And it gives me 16.26 degrees. The question normally wants us to write 3 significant figures, so we're going to say 25 sine.
Oh no, I've done it wrong.
Theta plus 16.3.
6 away, so 16.
Okay. Is that alright? Is everything clear with how you go through doing that? As long as you follow the same process all the time, it's quite a straightforward step-by-step process. The next bit. Hence solve the equation. Hence solve the equation that equals 12. Well, all that means is we're now taking what we've just found and putting it equal to 12. So we're now saying part 2, 25 sine theta plus 16.3 equals 12. And this is not actually that far removed from a core 2 kind of question. So we do inverse sine on that, inverse sine of 12 over 25, and the calculator says theta plus 16.3 is 28.696854. Again, this is up to you, and I know that some of you have learnt this by drawing a little diagram and actually drawing the sine or cos graph and marking it on there. I learned this, I teach this by doing the class diagram, but it's entirely up to you how you go about this next bit. We've just got on our calculator a figure of 28.69. It was sine and it was positive. So the two bits where sine is positive are there and there. So we mark our 28.69 angle with the horizontal in those two quadrants. So as we count round, we've got 28.69. The next angle we come to would be 28.69 less than 180, which is going to be, what, 151.3. And the question wanted us to find the values of theta between 0 and 360, so we've got the right two. We're going to take 16.3 away from each of these.
Find the value of A and hence 2.
Are you alright, Okay. So we get, what is that? Is that 12 points? Yeah. And the other one?
12.4, 135.
Both 3 significant figures. There we go. Alright. Thanks, Robin.